warm welcome back once again to Professor Valentin Troll.
Thank you so much, Robert. And yes, I was a bit disappointed today. I was so keen to go up the Eldfell volcano in Heimaey, but well, it is what it is. So thank you for joining me this afternoon. And this was a presentation I was keen to give next week on the second leg of the cruise. But several people said, oh, I won't be here next week. Could you talk about the current situation on the Reykjanes Peninsula? And well, as the gods of volcanoes wanted, here we are. And I can give this presentation now for those who are leaving us, and of course for those of you who are interested. As you know, the Reykjanes Peninsula has been waking up over the last few years and has produced some spectacular volcanic eruptions, and I'm going to talk a little bit about this today. So, a few slides to get us warmed up. Just a recap, I've talked about this before, nothing new, but Iceland sits on top of a spreading center. The Atlantic plates, they spread with about 2 centimeters a year, the North American plate on the one side, and the Eurasian plate, as we call it, on the other side. And in addition to that, Iceland is fed by a hotspot or a mantle plume, and the two things together, they make Iceland such a prolific site for volcanic activity, and this is why Iceland is above the sea level, and we have volcanoes, well, erupting quite frequently, and this has been going on for quite some time, several tens of millions of years. The Atlantic has been happily spreading for quite some time, and eruptions can now be, or old eruptions can now be found in Greenland, for example, as well as in the UK. We passed some of them. These are from the proto-Icelandic plume, as we say, when the Atlantic was still merged together. There, the Irish and the British volcanoes and the Greenland volcanoes were very close to each other, but now they have drifted apart because of continental drift, and Iceland is still kind of in the center of it, and it's still going strong. Now, the Reykjanes Peninsula, it's that little knob, that little nose that stands out. And, well, it's where Reykjavik is, hence the name Reykjanes Peninsula. And it's this thing that continues submarine for quite some time. Only part of it is above the surface. And it's been volcanically active for quite some time. And it's been dormant for the last few hundred years, but only 3 years ago, it came back to life. So, we call this a leaky transform fault. Well, geologists have to have their special terms, of course. You don't have to worry about the term. What it really means is if we have two plates and they slide against each other every now and then, you get some crackling in the middle and it opens up, and that's where lava can rise up. So, we have these volcanic systems that are elongated, they are stretched out, and this is because the plates are moving ever so slightly against each other. It's an oblique opening. When they tell you that the plates are rifting apart this way or drifting apart this way, is not quite true. It's much more complicated in reality. It's more like this. So, and this makes the situation a little more complicated. And I said the Reykjanes Peninsula was very active in the past, and now it reawakens. And here's the evidence for that. This is work by Icelandic colleagues. This is what geologists do. They look at the rock record, and we believe that this is something meaningful. What it means is we can see when volcanoes were active and when they were dormant. So, over the last 4,000, 5,000 years, there was 3 major eruption intervals on the Reykjanes Peninsula. Each of them was followed by several hundred years of dormancy. So the eruption period on the bottom here on the right-hand graph, it's called eruption period 3. It lasted several hundred years, and then it was followed by a gap of activity. The gap, depending on which volcanic system we look at, was between 700 and 1,000 or 1,100 years. And then another pulse of eruptions happened. Again, several hundred years of intense activity, followed by a gap. And then, round about the year 1000, another period happened, listed here as eruption period 1, and several hundred years of intense activity, followed by dormancy. And just now, after another 700 to 800 years of dormancy, the Fagradalsfjall volcano started to erupt again. And all the geologists go, oh dear. So what it means is that we may be in for another period of several hundred years of intense activity. And I'll talk a little more about this later on. But let's plunge into the eruption now. So in December 2019 and into March 2021, it started to rumble on the Reykjanes Peninsula. There was an increased number of earthquakes, and several of them reached 5.6. Some of you have surely experienced earthquakes. The strongest I ever experienced was in 7.5 in Indonesia, and that was seriously unpleasant. Let me give you a flavor. 4 is when cups fall off the shelf. 7, it's a logarithmic scale. 7 is really intense. So 5.6 is a serious earthquake. Things get damaged. So this is how it started. And in the weeks before the eruption in March 2021, there was literally tens of thousands of tremors. That's a vibration in the ground. And we believe that comes from gas moving. And on the 19th of March 21, the eruption started early in the evening, 8:45, and in a place called Grindavík. So Grindavík was remote. It was off the beaten track, and nobody really lived there. There was no grazing animals, so everything looked quite harmless. And indeed, within days, literally thousands of people flocked there to watch the eruption. And, well, initially a 600 to 700 meter long crack opened up, a fissure, and that was ejecting lava. And in April of that same year, 4 craters had formed along this fissure system, and lava output had been somewhat reduced with time, but it was going for quite some time. So here is some of the earliest lava from that day, from the initial eruption, and within a few hours, a little hill, a little volcano mount had built up, which you can see in the top left. There is a little hill forming there, and the lava was going over soil and moss. And one of the really unpleasant things there is, of course, the moss fires, because there is not a lot of vegetation, and the little bit of vegetation that is there, it catches fire very quickly. So a lot of the gas that we see is actually smoke from burning vegetation. So the eruption continued, and I have a little time sequence here. This is from one of the cams, on the webcams there. There's a live cam, of course. Nowadays, there's plenty of them. And I'll show you a little impression of how this volcano built up. So now it's night, it was day before, so this is really on a actually very short time scale. And Icelandic weather is, of course, part of it. Here's the next night, so this is just about 2 days now. And the weather. So, and within a few days, the initial valley of Grindavík, it was kind of full with lava. And this is the third night of the sequence. And I guess we can stop here. You get the idea. So what happened is that this fissure opened up and it formed a row of craters. And as so often, what we find in these situations is that one of the craters takes over. One of the craters becomes the dominant one. As so often, many companies start out producing something similar, but then one company takes over and does the thing. It may not have been the best at the beginning, but like here, it wasn't the biggest vent that was starting off. It was actually vent 5. The 5th in the series that opened up, and that became the dominant vent. And by May, this was the only vent that was active. So let me give you a few impressions here. So this is the initial fissure that opened up, and there you can see a long crack in the ground, and lava is emitted there. So that's what usually happens. And all the other subsequent eruptions, all the 8 eruptions we have experienced in the Reykjanes situation now started like this. A crack opens up between a few hundred to several kilometers long, and then individual vents form along this crack. So here you start to see a little crater row that forms, and then lava is flowing away from those, of course. So this is vent number 2. This is the second vent that opened up, and there's a little helicopter there for scale. And that is, of course, there's a lot of surveillance, of course, going on. But it was all very remote, as I say, so there was no danger really to anyone at that point. So this is vent number 3, and it produced a lot of spatter, and this is why they get so steep so very quickly. We call them spatter cones. It's a lot of little fragments of lava. They're still hot, and they are thrown out, and they build these cones very, very rapidly. So here another impression of vent 3, and then at some point the walls break, and the lava that's boiling inside is starting to find a channel, and it makes a little lava river that is then draining towards lower ground. So here is a sequence, and is the different vents. This is from early in the eruptions, and there is vent system 1, vent 2 in the rear, vent 3 in the middle, and then vent 4 and 5 and 6. And note vent 5. It's actually one of the weaker ones. So it's actually quite a cool story. I like it a lot because you may not have an advantage to start with in life, but you may actually get one later if you work hard. And so vent 5, look at him. So he really took over and became the dominant vent of the eruption, and he was outshining all the others in the end. And let me show you vent 5 in action. There is sound to go with that, but we couldn't get it to work. It doesn't sound very nice, actually, so just to give you a flavor here. But yeah, that's vent 5, and you see how the spatter is thrown out, and this spatter then welds to the fringe of the volcano, and this is what builds up these spatter cones so quickly. They become very steep very, very rapidly, and very often the walls actually collapse. And the opening here is a collapsed wall, and then often the part that collapsed is, well, drawn away with the lava. So this is vent 5 in action, and here we have another one. Couldn't resist putting some videos in. And look at the interior of that wall just to the left. So these are inherently unstable constructions, and often they collapse, of course. They're hot, there's a lot of rumbling, there's a lot of activity, and you get the idea. So, and this is vent 5 when it was really strong in summer 21, and it formed a little lava lake, and the lava lake was starting to pulse, and that was a very interesting phenomenon. I had not seen that before. We wrote a little article about this, but here you have vent 5 and the pond or lake that formed, and it was filling up, and then it was overflowing and filling up and overflowing, and it did this in an incredibly fast rhythm. So let me run you through this. These are 2 images, actually. It's not just one. And we start in the top left, and it starts at 4:49 p.m. on that day. This was June 8th, 21. And then within a few minutes, the lava lake was filling up. And by 4:55, a little bit lower down in the sequence, it was overflowing. Once it had done this, the level of the lake was lower. And it paused for a quick second. And then just at 5:04, literally a few minutes later, it was starting to fill up again and erupted. It was spilling over, and then it subsided again. And it did this for several weeks, very rhythmically, almost like Old Faithful. So it was really very systematic, very bizarre. And we have an idea why this is. I won't bother you with that. I think it has to do with the way the gas is coming through, but very intriguing phenomenon. And we form these lava pools. This is what I just pointed out, these lakes or pools. And they then, every now and then, they spill over. And when they spill over, you get these outbreaks or flash floods of lava. And they can then, well, they can then travel. And eventually, there was so much lava that the pools spilling over actually produced more lava flows that were going down the hillside and entering other valleys in the area. when you look into the crater 5 or vent 5 from atop, this is one of the drone images from there, and you see that it was crusting over very quickly, and then it was bursting through again. Spectacular footage. So I was really impressed. As I said, lava was so plentiful that it spilled over, and here we have lava spilling from the higher ground from Grindavík into various other valleys, like the Nathagi Valley, which was a little further to the south. So here's two maps, official maps from Iceland, and initially the eruption was very constrained to Grindavík with a crater row, but on the right-hand side, within just a short time, the lava was spilling into the various places. There was real concern at the time about the Nathagi Valley, which is down here, because it spilled into there and it almost reached the roads here. And here's the coastal road, and this would have been a bit of a disaster because that's a lifeline for the village of Grindavík. But somehow the volcano decided, not today. So it didn't happen. And here we have the final extent of the lavas, and there's an image in the top right when the lava was spilling into the Nathagi Valley. There was a lot of concern at the time, and I have a little video here. Again, it's one of those time sequences that are cut very short, so let me run that for you. This is the filling of the Nathagi Valley. And there you see an interesting phenomenon. See, the lava is actually inflating. So there's not a lot of activity on the surface. So there is actually lava flowing under the crust. Nowadays, with all these surveillance methods and our camera opportunities, we can actually see these things. This was not possible in the old days. And as I said, the key issue is actually in this case, or was in this case, the coastal road. And here on the right-hand side is a map that gives the thickness of the deposits. And down there in Nathagi, it's not so thick, it's just a few meters thickness of lava. But up in the vent area in Grindavík, we have literally hundreds of meters of thickness around the vents. And what happened then is the Icelanders did all sorts of things. They tried all sorts of things. And this, actually, in hindsight, was extremely useful because now they actually know how to build lava dams. At the time, they started to build the first lava dams. They also did these experiments. They buried cables, all sorts of cables underground, and they wanted to know what happens if lava flows over these. And, well, we learned an awful lot. The big realization was that if the lava comes in the right directions with the right thickness, these barriers will actually help. If the lava comes with huge force and super fast, then, well, it will run over the barriers. So putting the barriers in the right place can be really, really advantageous. And I'll say a few words towards the end of the presentation about the current situation where the lava barriers have proved extremely useful to save the Svartsengi power plant and the Blue Lagoon. So then, well, the volcano was very popular. Loads of people went there. Some people claim it saved Iceland from bankruptcy because Iceland is heavily reliant on tourism. And this was COVID, remember? So not a lot of people did travel, but the volcano attracted a lot of folks. And there you could see that a lot of people gathered around the volcano. Some of them with bicycles, others on foot. And several small accidents happened to tourists, but nothing too serious. So then the eruption stopped in late 21, and we all thought, oh, it's over. But then in August 22, it started again in Meradalir, just in the neighboring valley. And here's the vent, the main vent in Meradalir. Again, it started as a fissure system, and that was towards the end of COVID. And then loads of folks went out, and this was also where you could travel freely. So this is us trying to sample there. And again, there was a lot of tourists coming there. So 10,000 people were there within the first day after the eruption started. Can you believe that? So the 22 eruption, it started off with these deformations that we see today, and usually you can see that the ground is swelling up for days to weeks before the eruption, and that's what's going on right now today on the Reykjanes Peninsula as well. The ground is swelling up, and it's reached a point that is about the same level of swelling as has been the case for the previous eruptions, and this is why a lot of people think it's going to happen again very soon. And these fringes that we see in the lower right-hand diagram, this is satellite data. When you superimpose the satellite images, you can see the deformation, and that tells us this ground is actually lifting. So how does it look on a map? Geologists love maps. So here's two maps. The left-hand side is the Grindavík 21 eruption, and on the right-hand side in red, we see the Meradalir eruption. Again, a fissure, and then lava flows coming off this. So this is the fissure. It cuts the hillside at Meradalir in August 22, and within a few days, one main cone started to develop. And this is my colleague, Ariana. She's an assistant professor in Raleigh in North Carolina. And her students and mine and etc. We were working there and we were inspecting this. And there we are just at the end of the fissure. And you see the cone behind it. And at the very end of the fissure, we found this tiny little baby volcano. It actually started off as a little spatter volcano, this thing on the right-hand side. It's the furthest extent, but it never grew. So somehow this was one of the earliest vents, but it never became a real volcano. So here you can see a tiny baby volcano. So here we are looking at this fissure system, and this is the line in red, which is the fissure, and you can see the main cone behind, and the little baby volcano is just there at the very front. It just erupted for a day or so, and then it gave up. Here you can look into a tiny baby volcano, and there is my boot for scale to give you a flavor of how small this volcano actually is. So here's the fissure again from very early, and you can just about see the fissure was running uphill. It's not the lava flowing uphill, it's the fissure that cracked the mountain uphill. And then, of course, everybody flocked there, all the geologists, including myself, taking selfies there. We couldn't resist. And then here, 10th of August, and you can see the volcano is not super big at that point. 2 days later, the volcano is much bigger. And a few days later, 13th, the volcano has grown a substantial amount, and this is August 15th. So within a week, this cone built up, and it's now tens of meters tall. So then eventually the site broke, and the lava spilled out, and it made a large lava flow. So let's see, there's a little video here. I hope I can get this going. This is an overflight. Oh, now the sound is coming. Good. And those of you who have the opportunity to go with a helicopter, well, if the volcano starts tonight, then that's what you're going to see tomorrow. So the lava then produced a new lava field, and it was partly running on the lava of the previous year, and that led to some very intriguing situations. So in some places, the lava of 22 was covering new ground that hadn't been affected by the 21 eruptions. So here's a few points with the blue dots there. There we actually covered new areas, but in many places the lava was flowing over the older lava. Here's one of the places that was new ground. This is lava from 22 flowing into a new valley, and there you can see it picks up rocks. It forms this thin deposit, and there we have 22 lava at the lowest part. Sometimes you kind of face really awkward situations when you are in these kind of fieldwork situations, and that is, you know where the lava is flowing, and you realize, oh, the new lava is coming. So you suddenly have this kind of big idea. Oh, damn, this lava will be covered very soon. So you run out and try to sample the old lava because you know soon it'll be buried. And we did this a few times. So this is me trying to get rock samples from the 21 lava, because 1.5 hours later, it looks like this. The new lava is coming. And then you can actually sample two lavas, the 21 and the 22 lava, in one go. How convenient. So here we have another situation like this, and here I told you about the moss fires. They're very unpleasant, the vegetation fires. And here the white smoke is actually moss fires of, in this case, the 22 lavas burning the vegetation. So then sometimes you have really awkward situations where lava is pushing each other around, and this is also what happened there. So here we have 21 lava being pushed around by 22 lava. The shiny material in the foreground is the older lava, and the new lava is coming from behind, and just in the center of the image in the far distance, that's the vent of 22. And this new lava then pushes the old lava and it breaks it up into chunks. So here's some chunky bits of Pahoehoe lava broken up by the new lava. And here it is, quite massive bits that are broken up. There's quite some force behind it. And here you go. It looks quite chaotic and messy in places. And here you can look under the surface of a lava, and this is how this inflation comes about, this phenomenon that lava rises. There is new lava flowing under the crust, but also gas is accumulating. It's pushing the crust up. And there you have these empty spaces, now empty, but of course at the time they were filled with gas coming out of the lava. So here's another example of gas pockets under the crust. And this is why you must not lightheartedly walk over fresh lava, because there's holes in the lava underneath. So what do geologists do there? Well, we love to classify rock types. So here we have a whole range of different rock types. They're all chemically very similar, but there's of course massive lava. There is Pahoehoe lava, blocky lava. There is also pyroclastic eruptions from the fire fountains, and of course geologists collect them all. I will not go into detail. I will just show a few examples here. The lower images there are electron microscope images where we can actually identify the tiny little crystals in the lava as well. But one rather stunning rock that was discovered there was a peculiar type of pyroclast, a peculiar type of tephra. It was called the golden pumice. And here we are. This is a golden pumice, and this was thrown out of the vent, and it's chemically identical to the rest, but for some strange reason, it is golden. Here it is. So, and of course, all the geologists were really keen to get samples of this, and a lot of people asked me, how can this be? And here's my explanation for it. I think it's like Coca-Cola. So we have Coca-Cola in that glass there, and we have the massive liquid, which doesn't have a lot of bubbles, and that's dark, but then the really bubble-rich, frothy material, the foam on top, that's actually a different color, because light is passing through this in a different way, and therefore it looks golden. And I think Coca-Cola explains the golden pumice. So, here a few more impressions. Now I'm going to talk a little bit about what we actually do in the field when we sample, and I call that personally, we're engaging the lava monster. This is after watching too much Disney, where the lava monster was kind of, you know, a major theme. And first of all, well, you have to get your gear ready, and here's a list of all the things geologists need. And we don't have to go into all the details, but you do your checklist and then you get ready. It looks wonderful, but once you're in the field, everything is more complicated. And what you realize is, in order to actually sample lava, you need a lot of water to cool it down, because you can't touch it. And here we are starting to actually bring in all sorts of old pots and pans in order to actually have water in there. Then what you also need is, you need to worry about the gas. So you bring your gas mask, and then eventually you're ready, and you have a little gas meter. See, on my thigh, there's a little orange device, and that is actually a gas meter. That starts beeping if there's too much gas in the air. And it's carried low down because CO and CO2 is very heavy, and there's gas traps in depressions. And this is actually really dangerous. Most volcano accidents happen in gas traps. That's why you carry it low down, so that you can walk away once you get an alert there. So here you look at what you need to do, where's the wind, how's the gas, how is the lava moving, and then you can actually start sampling. And of course, you need to have your equipment, you have your hammer, you have your thermometer, and you have your goggles. And once everything is ready, you can actually go, and you have your gas mask, of course, ready as well in case there is an alert. Then you have to check the temperature because you don't want to touch this. I've seen people touching hot lava. It's not good. You spend a day in hospital, and therefore you want to be very sure. Now, if it's open, if the ground is open, then it's easy. It's a piece of cake. You can go there, sample your lava. If it's thin, you just hammer it off and you bag it, and that's it. So all is good. So this is Ariana and myself sampling the lava there. So all good. If the lava is liquid and it's open ground, again, easy. You can scoop it up. If you're starting to be in depressions, it gets a little awkward because then you have gas and your escape routes are more complicated. So you need to be a little better prepared. And if you take hot lava and you remove it and you put it on dry moss, actually the moss will start to catch fire immediately. So you sometimes have to work as a fireman as well, because when you sample, you actually might cause a little fire. This is what happened there. So eventually you have this rock sample. It's still 100 degrees hot, but it's just about good enough to be touched with a thermal glove. And then you can continue sampling. So this is us sampling lava, and we did this for weeks and weeks on end. So when the lava is very thick and in valleys, it gets more challenging because there you actually have gas concentrations, and as I said, your escape routes are more complicated, and you need to be concerned that there could be a breakout. It looks like that the lava is sturdy, but it's liquid inside, and it could actually have a tongue coming out any time. So that means you have to take a lot of measurements before you take a sample. The actual sampling is very quick. The thinking beforehand is not. And in some cases, you have really complicated situations. There, you sit there and watch the lava for an hour before you take a single sample. So eventually, when you're ready, you can do that. And here's my colleague Lucas and myself ready to sample with our scoop, our lava scoop. And I'm going to show you a video of me showing off now how we scoop up lava. I'm going to take a lava sample now. It's a liquid lava sample, and it's going to come from this place there. So let's have a look if this works. So, and then you do a lot of this, and eventually we have sampled 150 of those Teflon liquid lava samples. We sampled the entire thing, and there you see me rather exhausted after a while, and taking a little, actually well-deserved rest, I felt. So, but here is our map, and all of the little numbers on the map, they are actually samples we took, and they allow us to come up with a time sequence for chemical evolution. We don't need to go into details, but one important thing is that the chemistry of the lava has changed during the eruption, and we wrote several articles about that. So we have a lot of geochemical data now, and here we can see how the evolution of the lava took place. And once the Meradalir eruption stopped, we were very happy because we wrote up our story. It was published in June 29th, 22, and we got this published high profile. Everybody was very happy. We thought the show is over, but no. Litli Rutur came, the next eruption. Well, within just a few days, we had another eruption in our hand, and this is now on the map on the right-hand side, the area in red. It shifted a little to the north, but there we had a large eruption forming, and again we had this cone that took over, one single cone, a new lava field, and the lava field was eventually covering lavas from the previous eruptions. So let me show you the cone. When you look at it from the ground, it looks like what you see in the bottom right, but actually once you send a drone up, once you send a drone up, you can look into the crater, and it's really boiling lava in there. So I think you get the idea. And here we have the new lava of 23 covering the 22 lava. And there is a very complicated stratigraphy if you think about it in detail, but spectacular to watch. So there's the lava front in this image here, the new lava front covering the old lava from the previous year. And there in the bottom right, we actually have a fantastic, geologically fantastic situation. We have a substrate of 21 lava covered on the left by 22 lava, and the 23 lava is coming in on the right-hand side, and eventually the three lavas met. And this is, of course, fascinating for geologists. And then there was this one place where all the lavas met once the 23 was going a little further. And there we had a sequence of 21 lava covered by 22, covered by 23. And we went there. And there you see us standing as if we had shot a lion. And ooh, look at us. We are at this one place where all the lavas are stacked in the right way. But we learned a lot during the eruptions, and a little later we got a donation from one of the steel companies, and they realized that we are sampling kind of in t-shirts, and they provided these suits, these space suits, and that was a complete game changer. Not in terms of the sampling, but in terms of the media attention. Suddenly everybody wanted to see us doing this, and we have some YouTube videos with, believe it or not, 50 million views. Beforehand, when we were there in our old kind of, lumberjack shirts, then nobody cared. So this was a game changer. But the sampling is the same. We still take the scoop, and we scoop it up and doing that kind of thing. But let's now come to a slightly kind of bigger picture. I'll bring you back to this here. So now, after these three eruptions, we realized that this is not just one eruption. This is actually the beginning of a new eruption cycle. And that led us to conclude that we will have more eruptions there. So the reality is there is more eruptions coming. We have to accept this. And then we had to start thinking about what is the real problems on the Reykjanes Peninsula if there is more eruptions. Well, let me run you through that. So this is the site of the 21 and 22 and 23 eruption, and it's kind of in the middle of nowhere. But there's various other things around. There's Keflavik Airport, there's the town of Grindavík, there's Svartsengi power plant, and there's the Blue Lagoon. So let me zoom in a little bit here. This is a map from 21. There you see the volcano, that's the bright orange spot. You see the lava field. And there's the coastal road, there's the town of Grindavík, and the Blue Lagoon and the Svartsengi power plant. That's the blue little spot there in the red circle in the top left. So the Blue Lagoon is a huge tourist attraction. It's one of the biggest revenue sources for tourists in Iceland. And well, the Keflavik Airport is the only really seriously large international airport in Iceland. And this sits on the peninsula as well. So right now, I think the Keflavik Airport is not really a danger, and the eruptions are comparatively small, so there was no problems with the air traffic. Every now and then you get a bit of a gas cloud, but it's very low, so the airplanes can go around. It's not a big problem. And sometimes you get condensation. So here is actually not an eruption cloud. This is a condensation cloud where water condenses around particles that are emitted, or aerosols, meaning larger molecules from the volcano. But if we look at the geological record, and this is a complicated map, we don't need to go into details, but let me show you the pink, the strong pink colors there. That is eruptions from the last eruption cycle, round about the year 1000 AD. And as you can see very quickly, these eruptions reached the south coast as well as the north coast. And they were even going into what's nowadays Reykjavik. So if this is anything to go by, we have to be a little concerned. And there was a huge debate because we have this aluminium smelter here. So here's a picture of the aluminium smelter. And the geologist said, well, it's not a good place for an aluminium smelter, but the mayor of that town insisted to have it because it brings a lot of revenue. And let me show you, the aluminium smelter sits exactly here, where the lavas of 1000 AD were hitting the coast. And there's still a depression. if there's more eruptions, if the lavas actually spill to the north coast, the aluminium smelter may actually be in the way. So this is big concerns that we have in the Reykjanes Peninsula. I should also point out that 70% of Iceland's population lives on the Reykjanes Peninsula, mainly in Reykjavik, but this is a bit of a serious issue. And I should then point out Keflavik Airport on the left-hand map, it's the little red circle there, is the only main airport there. The other ones are in Egilsstaðir and Akureyri, and they're a long, long drive away. If you had to supply Reykjavik with air bridges from these airports, it would be very awkward. So then, in summer last year, the eruptions at Fagradalsfjall stopped, and it's not over, unfortunately. The volcano shifted. It shifted towards the west by a few kilometers, and the Sundhnúkar eruption started. This is part of the Svartsengi system, and unfortunately, that now hit infrastructure. It was no longer a happy little tourist eruption. It suddenly became a rather awkward, serious situation. And here we had lava intruding into the town of Grindavík, and not many houses, but several houses got destroyed. And the lava barriers were helpful, but they couldn't quite stop one of the eruptions because the vent opened inside the barriers, and there's nothing you can do about this. So here's the map. On the right-hand side, you see the eruptions of Fagradalsfjall, and on the left, you see the Sundhnúkar eruptions. This map is already outdated because the lava field is already bigger. This doesn't take the June 24 eruption into account, which reached the town of Grindavík. So I went to Grindavík just a few weeks ago, and that's how it looks there. There's lava incursions into the town, and some of the houses got destroyed. It's closed off. The town is evacuated, so you need a special permit to go there. And the lava did not go all the way through the town. It stopped at some kind of place. And if I was the owner of that garden fence there on the right, I would market this. I would say, I have this wonderful new fence that can stop lava. So, of course, we all know this is not the case. It was sheer coincidence and luck. This is a video I took just in April this year. And this is just to give you a flavor how magma moves. The weather wasn't better. And now the video lets me down. Here we are. But the situation is now that here on the right-hand side map, the beige colors and the orange colors, that's the lava field. The lava has now reached Grindavík, and the lava barriers, that's the thin red lines, they are actually very helpful because they have diverted the lava to go round about the town. These lava barriers, you can see one in the bottom left. Basically, they are just dams made of earth, and there's a whole fleet of caterpillars and trucks doing this. They are on standby all the time, and they can close them and open them as they please. They can also fill roads over lava again, so within a few days they can actually build a new road over lava. It's quite impressive. But the big reality is that we have quite some problems. In the upper part of the map, let me show you here. Here we see lava that has gone around the lava barriers. Here's the Blue Lagoon, and here's the Svartsengi power plant. The Svartsengi power plant also has a investigation site, a laboratory, where we're trying to fix carbon into the ground, the CarbFix laboratory, and all of these installations are at risk. So here is the Blue Lagoon and the Svartsengi power plant behind. Well, the Blue Lagoon, the water comes from the power plant. It's the leftover waters that are used for the Blue Lagoon. And in the background, you see that road that goes from left to right, passing the Thorbjörn Hill on the top right-hand side. And that road has been covered by lava 3 times now. So if there's a new eruption, it's estimated that lava will cover this road again, and within about 2 to 3 hours, it's likely that that road is cut off again. Now, how will this all continue? I think we will have more eruptions. And here is a timeline: Geldingadalur, Meradalir, Litli-Rutur, and then Sundnúkar. We are waiting for the 9th eruption now, and the speed, the frequency of the eruption seems to increase. So there seems to be more eruptions, and they come in quicker succession. And several people asked me, how do you know that there's another eruption coming? So I downloaded these diagrams this morning. This is from the Icelandic Met Office. It's a little complicated, but let me run you through that. If you have a magma reservoir and it inflates, you can calculate from the inflation how much magma is accumulating, and that's what's drawn up on the left-hand side, magma volume for these two diagrams. And here is the inflation of the last eruptions. So here we had inflation, and the star means eruption. So each of these led to an eruption. The squares means no eruption, the inflation stopped. So the red curve here, this one here, is the current one. The circle means nothing has yet happened, and this is actually from just about a week ago, the data. This curve has now moved up to about here, and this means the inflation is already stronger than we have seen for several of the previous eruptions. And that means the likelihood of an eruption is extremely high. So the Icelandic Met Office on their webpage says they are expecting an eruption within the next 7 to 10 days. How about Reykjavik? Is Reykjavik safe? Well, here you can see the eruption from Reykjavik. It's only about 40 kilometers away. And this was an important question, and I was asked by one of the scientific editors, can you say something about this? And they asked me to write a little article, which we did, and I have a few prints out there. We just published this. And here we came up with these 3 options in the bottom. So we don't quite know how the system looks like, but there could be a deep reservoir, there could be several small ones, and there could be a shallower, big one. If we have this right-hand situation, then Reykjavik might actually have magma sitting underneath it, and this could be disconcerting. So we did quite a bit of work, and the good news is that it's the same magma for the 2 volcanoes. Fagradalsfjall and Svartsengi have the same magma. It's just one volcano, actually. And the other thing is we can do some seismic tomography. It's a bit like CT scans, but for the Earth. And there we can see one magma reservoir that sits at about 10 to 12 kilometers depth. And let me show you. Very complicated diagram, I know. But here it is. So this is the main magma reservoir. And it's actually quite limited in size. It's only a few kilometers wide. It sits right under Fagradalsfjall. And here we have a kind of fork, and there's some magma rising up to the Sundnúkar cones and to Svartsengi. So right now, it's actually a comparatively small system. So if we go back to this, it's actually this model D, that is the most likely one, and that means there is no magma sitting under Reykjavik. So there is some reason for optimism, although, of course, not if you live in Grindavík. So let me bring this together. Here we have the Reykjanes Peninsula, and we have now 2 of these kind of 7 volcano systems being active. There is a possibility more could become active, and geologically speaking, we have to get ready for more eruptions. And this is just the reality, but we're learning a lot scientifically, but also practically, and also when it comes to emergency services. So, thank you very much for your attention, and if you have a chance to go there, you should actually get one of the really cool t-shirts they're now producing. Thank you very much.